Hello again, everybody. That first one I think was okay, so we're on to example number 2 using the Pythagorean theorem and square roots. Again, created this question ahead of time because it was something I knew we needed to look at. Same strategy as before. Across from the right angle, we know we have the hypotenuse. We know one of the legs, the other leg is missing. So we are going to be able to use Pythagorean theorem because this is a right triangle and two sides are known and the third side is missing. So labeling our parts here again, hypotenuse, leg, whoopsie, just hit the paper, leg, and this one is, my perspective is a little off, so please forgive me here again. Pythagorean theorem, a squared plus b squared equals c squared. Or leg squared plus leg squared equals the hypotenuse squared. Okay, I'm going to move down again just so I can show my work. Again, I've had the question in the past, how do you know which leg goes in which spot? And it doesn't matter. You can interchange them. They can go in either place because it's an adding problem right here. The order of these two doesn't matter. There's a word for that. It's called the commutative property. For me and just my comfort with the algebra that happens to come next, I like x here and the other leg 5 here. And the hypotenuse is root 70. So again, remember, your legs are on this side. After the equal sign is the hypotenuse. And now we're ready to do the algebraic part. So here, x squared is first term, the spot. 5 times 5 is 25. And right here, the square root and the exponent of 2 undo each other, so this is just 70. Now this problem, the steps from here are more algebraic, so I'm going to draw my famous line that I like to use. Ooh, that's crooked. Laughing at myself right now. Okay. Harder to do than you think. We need to undo this 25, so we're going to subtract 25 from both sides. Wow, I tried to do this one without my glasses on, guys. Not the right way to go. Let me get those back on my face here. Slide down a little bit. Here we have x squared, and here when I subtract, I get 45. To undo the exponent of 2, I use the square root. I'm looking only for the positive answer because this is a length. Now 45, grab your calculator, try to type in. You're going to notice it's decimal. I can't do that right now because I don't have enough hands, but I can trust you that you know how to use your calculator for that at this point because we've been doing it for a little while. If not, ask each other. You guys are fast on those kind of things. Technology is your game. Here, for our factor tree, 9 and 5, 3, 3. So when you tried to use your calculator and did the square root of 45, you got a decimal because it is not a perfect square. When you run into that, that means you have to go back to what we did, a couple last lessons that I was there for, where we built a factor tree and we looked for partners. And when you had a partner, it meant there was an exponent of 2 and it could undo the root. The single had only an exponent of 1 and it was still in the root. So this is expressing our answer in simplest radical form. Radical is this symbol here. And we are going to go back to our work over here and write that x is 3 root 5. Again, I didn't have units clearly labeled in my original diagram, so I would just use the general label units.